Now we are going to review a very important parameter in animal breeding and genetics, and that is the breeding value. So the breeding value is used to rank candidate for selection from the best to the less performance. Okay, to explain this parameter to you, let's consider this case scenario. We want to select between these two boars the best for artificial insemination in view of producing highly performant kits. Good. Now, the two boars belong to the same breed, the same age, they were even bred in the same environment, but A is less heavy as compared to B. Now, the two boars, in view of assessing their potential, both are crossed each with a female goat belonging to the clone. It means the two goats are exactly genetically the same. And after crossing each of them with the clone, the results reveal that the kit from A is by far performant than the one of boar B, even though boar B was far heavier as compared to boar A. So, how can we explain these results? The objective of this lesson is for us to be able to understand that by the end of this presentation. So, the breeding value noted VE or BV is the genetic value of the animal. It's the estimated value of the genetic potential of the animal for a particular trait. It means the breeding value doesn't consider the environmental effects nor the interaction between the environment effect and the genetic effect. Okay, it is given by this formula. I'm going to read it. So breeding value is equal to 2 times the superiority of the offspring, and is also equal to 2 times the superiority that is being expressed as the average mean performance of the trait of the offspring minus the average mean performance of the initial population from where the parents of the offspring were selected. Okay, now for the previous formula to be applied, the following conditions shall be met. Firstly, the number of offspring should be infinite. We know that it is very impossible considering the condition of production or breeding farms or systems. Secondly, the breeding stock must be representative of the initial population. We also know that in reality this is not possible, since in animal breeding and genetics we deal with selection of the best of the best. So when we select, the breeding stock is no more representative of the initial population. And finally, the environment of parent and that of their progeny must be the same. Considering that all these conditions cannot be met, in view of improving the accuracy of the breeding value, since it is already biased, 2 important elements are used when the heritability is known and when the repeatability is known. Their incorporation into the formula of the breeding value improve on the accuracy. Okay, now when the heritability is known, now this formula previously used becomes this, that is breeding value is equal to heritability times the selection differential. The selection differential is this term, and which is the average performance of the selected parents minus the average performance of the parental population from which these are selected. Okay, now the second way to improve on the breeding value is also to consider the heritability. The most you consider many or more information or more parameters in the formula, so is it accurate. So when the heritability and the repeatability are known, the formula becomes this, where n represents the number of measurements of the performance, h squared is the heritability, r is the repeatability, Pn is the average mean performance of n number of repeated measures, and P here is the average mean of the population for the performance that is being measured. Now, if the heritability is not known, so the same formula is used, except that heritability is being replaced within the formula by the repeatability. Lastly, how about the use of the breeding value? We already explained that the breeding value is used to rank candidates for selection. It's only when they are ranked from the best to the least that effective selection can be done. Now, at the beginning, we're to understand what happened that the boa that was less heavier had the most performant progeny as far as the body weight is concerned. Now, to answer that question is due to the fact that the genetic potential of boa A was superior to that of boa B. Considering this fact, it means that the fact that boa B was heavier, as compared to boa A, that superiority could be due to the environment effect. In terms of environment effects, we have the permanent environment and the temporal environment. The temporal environment could be a disease or a pathogen. That means there is something that reduces the phenotype of boa A, and we know that any challenges or any environmental effect may only affect the phenotype but not the genotype. So the fact that A was less heavy as compared to B didn't alter or didn't change its genetic potential that is still superior. So dear students, thank you for following and see you for our next class.